Any questions over the homework assignment before we get started? 15?
Yeah.
From last night?
1.6.
So one of the things we can do with this here is plug it in.
I couldn't really ever figure it out.
Yes. Is that over it? All right. So the first one we're looking at is solving number, well, that's 13. Yes. Okay. So this is number 13, or sorry, 15. Now, if we look at this here, we have this three-variable system of equation. Now we can go on and type it into the matrix. It is a 3 by 4. And 15 is 1, 1, 1, 9. And then we have 1, 1, 1, 3. And lastly, we have 5, 0, negative 2, negative 1. So we type it in. All right, guys, let's focus up here. Now we can do second matrix and get our REF. And then second matrix A, and hit enter. I have a feeling this is where you got. Yes? So we get this matrix here. Now if we look at the bottom row, 0, 0, 0, 1 is telling us that the last row for our solution is really telling us that 0 is equal to 1, which does not work, so this is a no. Yep. Okay. Yes. I think this is it. Yep. Yeah, because if we get all zeros and then a 1 in the last row, that's no solution. If it's all zeros, then it's infinitely many. Questions on this here? All right. What we're looking at today is operations with matrices. We're looking at operations with matrices. Now the first thing is addition, subtraction. To be able to add or subtract two matrices together, the dimensions have to be the same. The dimensions have to be the exact same for us to add or subtract two matrices. Now you don't have to write these down, but here, the two that they gave us are 2 by 2s. Both of them are 2 by 2, so we can add them together. Add or subtract, and we add or subtract the corresponding elements from each other to get our new matrice. So if we look at this first one here, our first matrice is a 2 by 2. 2 rows, 2 columns. The second matrice is also a 2 by 2. So we can add these two together. And we do that by adding the corresponding elements. So we would add 2 and 1. Then we would add negative 1 and 2. And that would finish the first row. The second row, we would add 3 and 4. And lastly, we'd add 0 and negative 2. And at this point here, we can add those together. So 2 plus 1 would be 3. Negative 1 plus 2 is 1. 3 plus 4 is 7. And lastly, 0 plus negative 2 is. And that's it. Questions on this here? We ready for the next one? Perform the indicated operation if possible. So here we're subtracting. Now the first matrix is a 3 by 2. The second matrix is also a 3 by 2. So we can subtract the corresponding elements. So we'll start with 2 minus negative 1. So we have 2 minus negative 1. Then we'd have negative 3 minus 2. Then we can go to the next one. We'd have 5 minus, bless you, 7. Then we'd have 4 minus 8. Then the last one, we'd have negative 2 minus negative 5. And lastly, 8 minus 6. And now that we have this set up here, we just need to subtract the 2. 2 minus negative 1. Well, the negative and negative make a plus, giving us 3. Negative 3 minus 2 would be negative 5. Our next one, 5 minus 7 is negative 2. 4 minus 8 is negative 4. Negative 2 minus negative 5, well, the negative negative would make a 3. And lastly, 8 minus 6 is and that's it. Questions on this here? For the most part, yeah. All right. How about this one? Would 0 be an element? Well, 0 is a number, isn't it? Because it does hold the place of certain values where you have to put them in. So if I added zeros, would it change what this second matrix is? Well, what is it now? It's a 2 by 2 by 2, 2 rows, 2 columns. If I add 2 zeros, it's not a 2 by 2 anymore, it's a 2 by 3. So I'm changing the matrix to be able to do that. So this is a 2 by 3. Well, perform the indicated operation, what? So this is not possible. Because if the dimensions are not the same, we cannot add or subtract. Questions on this here? Questions on adding or subtracting? Yeah. Now, if we wanted to, so we can look at this one here. I could grab the calculator and say second matrix, go over to edit, and say the first matrix is a 2 by 2. So we have negative 1, 7, 5, 3. So the one that we're on, question A, where we're adding the 2, so I can put matrix A in the calculator. Say second quit, second matrix. But this time I can go down and edit matrix B. I can put more than one in. And the second part of this is a 2 by 2, so 6, negative 4, negative 8, 2. Second quit. So I've inputted the first matrix in as A, the second as B. So I've defined this one as A, this one is B. So we want to add these together. Yes? So what we can do in the calculator, first thing we can do is recall matrix A. So second matrix A. And we want to add to it second matrix B. And we get this here. 5, 3, negative 3, 5. Well, if we did the operation here, negative 1 plus 6 is 5. 7 plus negative 4 is, indeed, 3. 5 minus 8 is negative 3. And 3 plus 2 is. So again, there's some things that the calculator can do for us that is faster, like we saw with 3 variable systems of equations. It can solve it a lot faster than we can, but there's some things it can do that we can do a lot faster by hand, like adding or subtracting these matrices. So I think we feel pretty good with these here, yes? This one here would be no solution, not possible, because we have a 1 by 2 and a 2 by 1. Does not work. So if we feel good with addition, what we're going to look next is scalar multiplication. When working with matrices, a real number is often called a scalar. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. This is called scalar multiplication. Scalar, scale. We scale something up, we scale something down. That's really what we're doing. So if we do this here, we want to scale this matrix by a factor of 2. What we're going to do is multiply each element in the matrix by 2. So we're going to do 2 times 3. 2 times negative 2. 2 times 1. 2 times 5. 2 times 2. And 2 times 0. 2 times 3 is 6. 2 times negative 2, negative 4. 2 times 1 is 2. 2 times 5 is 10. 2 times 2 is, and our favorite multiplication, 2 times 0 is 0. And that's it. Questions on these here? And again, we can do these in a calculator. I'm not going to go in and put the matrix in, but we could say second to matrix A, and it would multiply the matrix by 2. If I want a fraction, alpha y equals enter, I could say 3/4 second matrix B. I can multiply the matrix by 3/4. It will do any number that we want. Questions on scalar multiplication? Only put one example of scalar multiplication in because, well, I don't think we need a whole lot more of those. Just multiply the whole thing by that number, yes? Now, we can combine them. We can do scalar multiplication and addition and subtraction at the same time. Now, if we look at these two here, they're both 2 by 2s. So the dimensions are the same, which means we can add and subtract. Multiplying by a scalar does not change the dimensions, it just changes the numbers inside. But the first thing we need to do when multiplying, when we have a scalar and then addition or subtraction, I want to apply the scalar first. So I have negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. So we'll do the scalar multiplication first, and then we will add or subtract second. Well, negative 3 times 5 is negative 15. Negative 3 times 0 is 0. Negative 3 times negative 2 is 6. And negative 3 times 4 is negative 12. Questions on this so far? Now at this point we can add the corresponding elements. So negative 15 plus negative 1, 0 plus 7, 6 plus 3, and negative 12 plus 2. combine like terms, combine them. So negative 15 plus negative 1 is 0 plus 7 is 6 plus 3 is negative 12 plus 2. Yes. Questions on any of this here? Now, again, we could plug this into the calculator. I would define this as matrix A, and this is matrix B, and say negative 3A plus B. And the calculator will do it for us. So especially when we have scalars, multiple scalars, and addition, subtraction, it could be faster to do it in the calculator. Questions on any of this here? Well, let's look at the next one. So we're going to distribute and multiply this by negative 7. So we have negative 7 times 2, negative 7 times 3, negative 7 times negative 2, negative 7 times negative 7, negative 7 times 4, negative 7 times 7, negative 7 times 2, negative 2, negative 7 times 5, and lastly negative 7 times negative. And then we just need to multiply them together. And we get this matrix. Questions on this here? We're ready to look at the next one. So one of the first things we can do is multiply by this scalar of 4. So we'd have 4 times 3, 4 times 5, 4 times 4, 4 times 2, 4 times 0, and 4 times negative 2. Now we can leave the negative alone. Now I will say if we said minus 4 times this matrix, we can multiply the matrix, the second one, through by 4, and then subtract what we get. Or if you multiply through by negative 4, we would change it to addition. So since there's not a scalar, we can leave it as subtraction. 9, negative 6, 2, 7, 5, negative 3. Now at this point here, we're going to do our simplifying the 4s. 4 times 3 is 12. 4 times 5 is 20. 4 times 4 is 16. 4 times 2 is 8. 4 times 0 is 0. And 4 times negative 2 is negative 8. And now the last thing we need to do is subtract. So our corresponding elements is going to be 12 minus 9, 20 minus 7, 16 minus negative 6, 8 minus 5, 0 minus 2, and negative 8 minus negative 3. Well, 12 minus 9 is 3. 20 minus 7 is 13. 6 minus negative 6 is 22, because the negative negative makes a positive. 16 plus 6 is 22. 8 minus 5 is 3. 0 minus 2 is negative 8 minus negative 3 is negative 5. Because it makes the 3 be plus, so negative 8 plus 3 gives us negative 5. Questions on any of this here? We ready for the next part? That's it.